Hello, it's Mr. Bush here, and we're going to go over a real quick review for the CA that's going to be on Monday. So first off, we're going to start off on our first topic here, which is going to be speed, velocity, and acceleration. I get it's going to be a little messy, but we're going to get basically a 6 weeks and a half worth of work crammed into one small video. So if you look here, all speed is some sort of distance divided by time, typically measured in meters per second. So miles per hour, something that's just a certain distance in 1 unit of time. Alright, let's look down here at velocity. Now this one is also very similar to speed. Basically, velocity is just your speed plus your direction. Example, if you were going 50 miles per hour, that's a speed because you have no direction with it. If you were going, let's say, 50 meters per second north, that's a velocity because now you have a direction. So it's just your speed plus your direction. Alright, let's look down here at acceleration. Now, acceleration is just any change in velocity. So anything that would change your velocity. That means speeding up. If you get faster, that changed your velocity. So make sure whenever you write down speeding up, draw that little arrow. Slowing down. So the little arrow that goes down, that means you've actually decreased your speed. Here's the last one. If the object turns, that changes your direction. Right over here. And that's going to be an acceleration. So speeding up, slowing down, or turning. Alright, that covers basically speed, acceleration, and velocity. Let's look at Newton's first law. If y'all look here, it's called the law of inertia. What that means, what inertia is a resistance to any change in its motion. So, an object in motion or an object at rest will remain that way until it's acted on by an unbalanced force. Basically, that means that there's an outside force. It'll cause it to either slow down or speed up until basically, or change its motion. Alright, so let's go ahead and look at what causes inertia. It's basically caused by mass. And that kind of makes sense. Heavy objects are hard to get to accelerate. It takes a lot more force to accelerate a heavy object. Or it takes a lot more force to stop a heavy object. Like if you have a car going down a hill. The heavier the car is, the more force it takes on the brakes to stop it. Alright, that brings us down. Basically, that covers Newton's first law. Now let's go ahead and transition into balanced and unbalanced forces. So, you'll see the term net force on the test. All that means is you've added or subtracted all the forces together, and the net force is the remainder of what you have left over. So if you look here, on this box, we have 7 newtons on each side. Now, if you push in opposite directions, you subtract. If you push the same way, you add. So these guys are pushing in opposite directions. You subtract 7 by 7 and your net force would be 0. If the net force is 0, the object is considered to have a balanced force. You look over here. Basically, a balanced force will cause the object to remain at rest or at a constant speed. Basically, it will not change its motion. So there will be no change in motion. So basically, a balanced force gives you absolutely no change in motion. Alright, let's go ahead and look down here at our unbalanced forces. So I'm just going to draw a line so we know that this stuff is dealing with unbalanced forces. If you take, let's say you had 7 pushing this way, 3 pushing this way, they're pushing against each other, so you would subtract, leaving you with a net force. So the net force here would be 4 in that direction. Now, if you have an unbalanced force, it will cause an object to move. That kind of makes sense. If someone's just standing there and then you push them, they're going to move. Now, an unbalanced force will cause an acceleration. So if y'all look here, basically the unbalanced force will cause an acceleration. Sorry about the messy handwriting there. So everyone, if you haven't already, draw this little circle thing. If you have an unbalanced force, it'll cause an acceleration. If you have an acceleration, you know there is a unbalanced force. And probably a really good example of that was this one right here. This little diagram had a sled moving along without any friction. Right here on section 1, it would have basically, the forces would have been balanced and it would not have sped up or slowed down. So at 1, you'd have balanced forces because there's no change in its motion. At 2, it would speed up because he's going downhill. So that would be an unbalanced force. At 3, you're going flat again, so the speed would stay the same. That's going to be a balanced force. There's no change in the motion. And at 4, he's going back uphill, which causes him to slow down, and that is an unbalanced force. Alright, let's go ahead and go back to the main review. We're going to transition into how we calculate force. So we're going to start up here. And this is going to be Newton's second law, or the law of force and acceleration. Now, the formula, which you will find on your star chart, and I will expect you to write down anytime you have one of these problems, is force equals mass times acceleration. So if you had, let's say, a 8 kilogram box, kilograms is always mass, and it was moving at 4 meters per second squared. That's always going to be an acceleration. So you just do exactly what your formula says. Basically, the point of a formula is so you don't have to think. You just do what it says. It says you would take your mass, which is 8, your acceleration, which is 4, multiply them together, and you'd get 24 newtons of force. So this box would be moving forward, would have a net force of 24 newtons. Alright, let's go ahead and look over here at this one. You have a gloriously drawn, this amazing masterpiece of a person on a bicycle. Notice he is following safety procedures and has an awesome helmet. So, if y'all look here, force equals mass times acceleration. The only problem is you have your mass, you have forces, but they're wanting to know what is acceleration. And this is going to basically be the problem on number 7 right here. Alright, so what we're going to have to do is rearrange it to solve for acceleration. First step, we would basically divide by mass. The reason why we're dividing is it's the opposite of multiplication, and we want to get acceleration by itself. But if we do something to one side of an equation, we have to do it to the other. So you'd have that divided by that. This will cancel out. And you're left with acceleration equals force divided by mass. Now our next step over here is to find our net force, because we have 84 from the wind pushing against him and 150 pushing forward. So you just take 150 minus by 84 and you are left with 66 newtons forward. Then all you do is just, once again, our formulas are here so we don't have to think. You take 66 divided by 100. If y'all remember on the test, I want you to set it up in this manner, like this. And you could either just move the decimal twice, or you could actually work it all the way out, and you are left with 0.66 meters per second squared. Alright,